It's on Canvas. Okay, the first one, again, adding or subtracting of fractions, but they have to have first the same denominator. So I'm going to change them so that they're both 15. Well, what am I doing to 5 to make it 15? I'm multiplying by 3. So I have to do the same to the top. So 9, and then this becomes 10. This is still negative. So I have the same denominators. One's positive, one's negative. So I'm going to subtract the two numbers. So 10 minus 9, which is 1. And I take the sign of the bigger absolute value. So this negative stays here, and it's 15. So negative 1/15. Okay? If I have two negative number, well, not even. If I have a negative 5.2 and I subtract 2.6, you're going to have to show work on this. I have negative minus 1. So what I like to do here is I like to change it to adding its negative. And now I have an addition problem that both the signs are the same. I have a negative and a negative. So with that, I'm going to add the two numbers. And you will have to show this work because this is on the no calculator test. Add your two numbers.
Why do you have to show work if you just figured it out?
7.8. But it stays negative, so negative 7.8. Show as much work as you can, or it will be wrong.
So when you subtract fractions, or when it says 9 minus fractions, you have to subtract that?
Yeah, because I have 9 plus a negative here.
Oh, yeah.
Okay, next one. I have, say, a square root, and it's a fraction, say 81 over... Oh, yep, sorry. Thank you. 81 over 100. To show work on this one, I'm going to show what times what equals 9, or 81. So 9 times 9 and 10 times 10. So this would be 9 over 10. Okay. Now, if, say it was... something like this, again, 16 over 100, so that would be 4 times 4. This will change. I'm just changing it because this is the problem is going to be on the test tomorrow. Showing the work, what do I still have to do to this? Simplify. So I'm dividing both the top and bottom by 2. 2 over 2, which becomes 2 over 5, and that would be my simplified answer. Showing that work is imperative. Ordering from least to greatest, you're going to have some numbers. You're not going to have to show much work on these types of problems. You're going to have, say, I don't know, square root of 6, negative 0.5, let's say negative 0.6, say 0.2, and the square root of 9. Okay, you're going to have to order these from least to greatest, and this is more, there's a lot of logic within these. So obviously, this square root of 9 is going to be bigger than the square root of 6, right? So we could put those two. And then we would want to see, well, square root of 9 is a 3. Is that going to be, is there any number bigger than 3? No. So that's going to be the biggest one. And then we have decimals, right? Well, this decimal's got to be bigger than any negative. So then we do square root of 6, 0.2, right? Now these ones, which one, if they're both negative, which one, without the negatives, which one's smaller? 0.5. So that's going to go first. So this is bigger than a half, right? So it's actually smaller, right? So it'd be negative 5.6 and then negative 0.5. Understand? Okay. If I'm adding numbers and they are, so negative 5 plus a negative 4, they're both negative, so I add them together and it stays negative. You won't have to show work on that one. Dividing fractions, don't ask why, flip the second and multiply. So you're going to have to divide fractions. So 2/3 divided by 5/10. Yep, keep, change, flip. So keep, change, flip. You can do the math out here. So 2 times 10 is 20, 3 times 5 is 15. If you look, you can see a top number and bottom number can be simplified before. But I'm going to just do it here where 20 over 15 can both be divided by 5. So 4/3, which would change to 1 and 1/3. Yeah, I would put it mixed number, yeah. Showing that work out. If I have a fraction, say 2/5, and I am cubing the whole thing, that means 2/5 times 2/5 times 2/5. Which it is. So it would be 8 over 125. If you can simplify it, simplify it. 8 and 125 cannot be divided by the same thing. Right? You're going to have to write an algebraic expression for a word phrase, remembering that your key words of product is multiply, difference is subtraction. See that? Simplifying. You're going to have to simplify an expression. Something like this. And you have to distribute this within here. So 1/5 times 25. So 1/5 times 25, which is 25 over 5, which is 5m, and then again 1/5 times 45, so 1/5 times 45 over 1. 45 over 5, which is plus 9. Okay, again, you have to show the work. Yes?
You have to show like 1 times 25 over 1 and stuff like that.
Yep, you will have to show this work. Well,
That's just mental math, though.
I know, but here's the thing, it's not going to be me correcting these tests.
So that's Mrs. Feist.
Mrs. Feist, and I would just show as much work so you get all the credit. Okay? Simplifying 2 fractions. I'm making a video for you because you were simplifying any fractions of the product. So like 2/3 times 9, 2. I don't know. 9/2. So if you're multiplying, you can simplify before, or you can do the math out and simplify later. So 2 times 9, which is 18, over 6, which simplifies down to 3. You can also do 3 and 9, both can be divided by 3. These both be divided by 1. There's only a 3 left, that would equal, right? Simplifying, if you're multiplying numbers, first of all, decimals, you're going to have to do some, we didn't do a whole lot of work with this, so let's review with 7.1 multiplied by a negative 2.8. So first you have to see that you have a positive and a negative, so your answer will be what? Negative. You're going to do your math out, so 7.1 times 2.8. You start here, right? 8 times 1, which is 8. 8 times 7, which is 56. What goes here? An X or a 0, right? Because I'm moving over to here. So I like to put a 0. So then I do 2 times 1, which is 2. 2 times 7, which is, did I do? Oh. And which is 14. add these two numbers, right? 8, 9, 1. I have 1 decimal place, 2 decimal places. So I have to move my decimal twice and have 2 decimal places down there. So my answer would be 19.88. Also, think of this logically, huh? Oh, yep, it's negative. Good job. Think of it logically. So if you get a number and you accidentally got, and you put your decimal right here, I have 198.8. Think of this, 7, roughly 7, because 7.1, about 7 times 3. 7, do you see how I just kind of rounded them and just thought of it logically? 7 times 3 is 21. How did I get 198? Oh, I did my decimal wrong. My decimal has to go to here. Now my number is 19. Logic. Simplifying an expression. So if you have something like 7 plus 5x, and over here is plus 5. Now, I want to simplify the expression. I can only combine terms that are alike. These two are not like terms. I can actually rearrange this a little and combine this 7 and this 5. Because I have parentheses, but because it's addition all the way across, those parentheses are relatively gone. So I can actually drop them if I wanted to, and I would do 12 plus 5x, putting that x first would probably be best. Okay, you're going to have to do order of operations in one of them. So I'm going to do one quick problem like that because it's kind of a quick problem. Let's do 2. This one was a common one that all right. First things first, I do what's inside my parentheses. Make sure to do that first. Last year I had a lot of kids that did not do that first. So inside my parentheses is 12 minus 3. My exponent is on the outside. I'm not worried about that right now. I had a lot of kids that did like only, never mind. Anyway, so subtract. So I get 9 on the outside. Okay, so now I have to do, right, 12 minus 3. Then I have to do that 9 squared, which is 81. So 162 divided by 3, which is 54. And I would show as much work, like I said, out. You will not have a calculator. So you're going to have to know how to multiply these two numbers and then divide by 3. Subsets. Remember that if I have the square root of a not perfect square, not perfect squares are all the numbers that are not perfect. So the perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Anything else besides that, if it was square root of, say, 53, is 53 a perfect square? No. So that would be an irrational number. Okay, one last one. I have a minute left. Shh. Look, this problem, you need to simplify it using, find the sum of or the difference of 2 so that it's an equivalent expression. You need to do 2x divided by 4 plus 7 divided by 4. And then simplify when you can. 2 and 4 can be reduced down to 1/2. That x can go up here or be next to it. I would leave it next to it. 7 over 4, you're going to leave it as 7 over 4. Okay?